Okay, this video is going to show why we need a different method for comparing strings than comparing numeric data. And so we're going to take a look at why we need a different method, and we're going to show what that method is. So at the very beginning here, what we want to do is we want to take a look at this program right here. And this program, you'll notice that we have a variable whose name 1 who's got Bill in it, and then name 2 is the same value. Name 3 we're getting from the user, and we're going to have the user type in Bill as well. So if we do that, then if we compare name 1 and name 2 as it's doing here, then it should say yes. And then here, if name 1 and name 3, if we have the user type in Bill, then it should say yes there as well. And then 2 and 3 should be yes as well. So all 3 should be yes because all 3 will be Bill. And so first of all, we will want to notice that if we were to compile this using these, you'll see that there is no problem with the compiler. And we're using the equals comparison operator. And so the compiler seems to have no problem comparing two strings like we would compare numeric data. So it gets by the compiler. But let's see what the results are. What does it show for the results? And so we'll take this out, and we go run, and we have the user types in Bill. So they all should be the same. But you notice then that it says yes for the first one, but then it says no and then no. And so well, what's up with that? And so what happens is, remember, these are we have been using the equals for comparing numeric data. Now we're comparing strings. Remember, you can't add strings, so why should you even be able to compare use comparison operators for strings if you can't even add them, multiply them, or divide them? And so that's kind of the idea here. So here's why there's an issue, and here's why it gets through the compiler. So what happens is it's string name 1. What happens is the compiler goes and it reserves a memory location just like we're used to up to this point. And so it names 1. But here's where it gets strange, is that it takes Bill and it doesn't put it inside the storage location named name 1 like we would want it to. What it does is it puts it somewhere else. So go ahead and do this on your paper. Put this somewhere else. Now, the next, and then what happens is, well, what's in name 1 then? Well, name 1, it puts the address of the location of the actual string. So it has a memory address. Think of these addresses as like a house. You have a row of houses and they have addresses, numeric addresses. And so that's what these are. These are like addresses, but in some places nobody's moved in yet. So on the mailbox there's no name. So this is kind of like somebody moves in. So the last name on the mailbox would be name 1. But it's referring to an address where Bill is really actually residing, is really in 1130. So what this does is it refers the compiler to where the string actually is. Notice the word refers. And so what happens is down in here, this first blank is string is a reference data type. So string is a reference data type. So because it doesn't store the actual string, but it refers the compiler to a storage location. That does. Now, I'm just going to write some notes up here. So what happens is ints and doubles are called primitive data types. And so what happens there is if it says that the int age, for instance, let's say that we had something like int age is assigned 15. Well, what it's going to do, it's going to create a memory location. Well, let's just use one of these. Now, don't write in here. Don't write this in here if you're following along. Don't don't put this, but let's say we have age is the name of this. And what it's going to do is going to take the 15 and put it right there. These are called primitive data types. And so if name 1 was primitive, it would put Bill right inside here. It would put Bill instead of the 1130. But it's not. It's a reference data type. So let's see. Let's pause this for. Okay. So what happens is as we go on here, then so we've got it referring to where Bill really is, the string. Now we have name 2. So let's put name 2 in the next one down. So this is a reserved memory location named name 2. And what the compiler does is it says, hey, Bill is already in a storage location, so we're going to not put Bill somewhere else as well. So we're just going to use the same storage location. And so name 2 will also refer the compiler to the 1130 for Bill, for the string. All right. Then it gets weird, if it's not weird enough already. Now we have the variable name 3. So we're going to go make another one called name 3, storage location. Right now it's empty. And so for this one, though, we're going to get user input. So name 3 is assigned the input of the user. Let's say the user types in Bill and hits enter. So what it's going to do, it's going to store it in name 3. Now, it's not going to store it actually right in name 3, but it's also not going to, we're not going to use this 1130. It's going to put Bill somewhere else. So when it's the user input, for some reason, it stores it in a different location than places where the programmer assigned a value. So this is the user. Now so it's a different location. And so what's going to happen is name 3, it's going to have 1131. So it's actually going to refer to the Bill, but it's going to be Bill sitting in a different storage location. All right, so this is what happens. And so let's go then and take a look at what happens here. So when we come down to these if-else structures, name 1 is actually has in it not Bill, but it has 1130. And so name 2 also has 1130. So this is why it gets by the compiler, because the compiler goes, okay, I don't have a problem because I'm comparing numeric data, and so that's not an issue. So, and then it compares those. 1130 does equal 1130, so this is true. So it's a yes. And that's what we had before. So here's where it works. Now let's go to the next one. Name 1 has 1130 in it, and name 3 has 1131 in it because it's the Bill that's in the storage location 1131. Now here it's comparing these two numbers. They're not equal to each other, so it's going to say no. And then the next one, it's going to be the same idea, 1130 for name 2, but name 3 has 1131. So once again, it's going to be no. And that's why sometimes it works here, and sometimes it doesn't work. And that's why we need a different memory location, or not different, a different method for comparing strings. Okay, I'm going to delete all the red. And so as we look up here, then a string variable stores the memory address of the storage location that actually holds the string, which is what we demonstrated over here. The string variable stores the address of the memory location that actually holds the string. You'd say that a couple ways. So comparing strings using equals equals is approved by the compiler because it's comparing memory location addresses. It's comparing memory location addresses. Oh my goodness, I cannot believe this. I don't know how it does that. So it's approved by the compiler because it's comparing memory location addresses, which are numeric data. Okay, so now, but this can produce inaccurate results, which we already demonstrated. Hence the need for a method that compares the actual strings. So we have a need for a method that compares the actual strings, not the memory addresses. Okay, so what we want to do then is we want to take a look at what are those methods. So number one method is the equals method. All right, so that's one method, and this method is case sensitive. And then, which means, so Bill is the same as Bill, but not Bill. Okay, so the point here is that Bill is capital B, and so it's the same as Bill here because it's capitalized, but since it's case sensitive, it will not be the same as Bill without being capitalized. It's sensitive to what the case is, whether it's upper or lower case. And then let's see if we can do this. And then the other method is equals ignore case. Equal ignore case is the other method. So Bill is the same as Bill and Bill. Okay, so Bill is the same as Bill with a capital B, and it's the same as Bill with a lowercase b because it's not sensitive to whether it's upper or lower case. All right, so that's important because sometimes if you're asking a user for input, they may capitalize something that, you know, one person would capitalize, the other person wouldn't. And if that doesn't matter to you, then you would want to use equals ignore case so it doesn't cause an error in the program. Now, so what are some examples then? How is this, what happens here? So let's take a look at this one. So what we would do up here is instead of name1 equals name2, we would go name, let's do an if name1 dot equals, and then parentheses name2, and then another parenthesis. Okay, so what this is saying then is that the value of name1, which is Bill, is it the same as the value of name2, which is also Bill? And of course that's yes. So it's comparing now the actual strings. So let's take a look at this one. So this is going to go if name1 dot equals ignore case, and so this is the value of name1 equal to the value of name2 irregardless of case, because it's ignoring it. Spelling, of course, is going to matter all the time, but irregardless of whether anything is capitalized or not. Capitalization does not have to match. And that might be one way to do this, is capitalization does not have to match. And so when we're writing a program, then we will look at this. So if you go back in then and change these, this would be a good thing to do, or you can just watch this. But we want it to go dot equals, and then put parentheses around this. All right, so that's one thing we want to have in there. We could then do the same idea here, only it's it's comparing name 1 and name 3. And then we could do the same idea here. And let's put ignore case here. All right. So let's say that we have the user type in Bill with a capital B. Then this is comparing the actual strings. If they're all 3 Bill, then we should get all yeses. And so when we compile this, we'll see that remember before it said yes, no, no. But in this case, it should say yes, yes, yes. As you can see, that's what it does because it's comparing the actual strings. Now, just for kicks, let's have the user type in a Bill without a capital letter, capital B. And so it's going to compare. So if we actually look at this briefly here, this is going to compare, and the second one is going to compare Bill with Bill with the lowercase, because name 3 is going to store Bill with the lowercase. And then this will be Bill I forgot to put name 2 here. I blew it there. All right, so it's going to compare Bill because name 2 is going to have the capital Bill, and it's going to compare that with Bill like this. Now you're going to have 2 comparisons that are using the same exact, everything's the same, Bill, Bill with lowercase, Bill, Bill, uppercase. The difference is this says equals, so it's case sensitive. Bill and Bill, this Bill and this Bill they're not matching, so this should say no, and this is capital B, lowercase b, but it says ignore the case, who cares, so this should be a yes. And so if we check it out, so in other words, this should go yes, no, yes. And of course, that's what it does because of the ignore case. All right, so that is how you use or how you compare, write code to compare strings. And that's it.